Alright, so this lesson is on graphing exponentials. The big key on these exponential. So what this means is that the x value is the exponent. Okay, so we're going to look at how to graph y equals 3 to the x power. So we're going to make a little chart here. Got our x's, got our y's. We're just going to plug in a few numbers around 0. Let's see. Start with -2. Plug in -2 for x. See what we get for the y. So 3 to the -2. Now to make this positive, negative fraction, move it to the bottom. So 1 over 3 to the positive 2, which is 1 over 9. Do the same for -1, plug that in. 3 to the -1, which is 1 over 3, so 1/3. And when we plug in 0 for x, so we get 3 to the 0 power. Anything to the 0 power is just 1. Plug in 1, 3 to the first power is 3. And we'll also plug in 2, 3 squared, which is 9. Okay, so now looking at the graph of this. So we've got our x-axis here, we've got our y-axis here. So -2 will go, this is okay, so we'll say this is -1, going over by 2's, -2, 1, and 2. Okay, so now at -2 it's 1/9, so that's pretty close to 0 down here. So it's not quite 0, it's a little bigger than 0, but fairly close to 0. Now at -1 we've got 1/3. Still, it's closer to 0 than 1, but it's fairly close to 0. Now, looking at when x is 0, y is 1. So x is 0, y is 1. I guess I could label this 1, 2, 3, so forth, so on. Okay, at 1, we got x is 3. And at 2, x is 9. So 3, 6, 9. And here's the tricky part for me, connecting the dots. So from there, anyways, you get the idea. We get this growing shape, growing exponentially. It's just going to grow up. As we go to the right, it's just going to get bigger and bigger. Now as we go to the left, it's just going to get closer and closer to 0. It's not ever going to quite touch 0. So it's just going to come right along the x-axis and just start getting closer and closer to it and never touch. Okay, this is what we call, so the line where it gets close to and never touches, horizontal. So horizontal asymptote. Okay, so the asymptote is the line that it gets close to, but it never touches. So in this case, it's at y equals 0, right on the x-axis. Okay, so the graph grows exponentially. Okay, now there are a few different things we can, a few different transformations we can do with this graph. Okay, so let's start over here. So if we had y equals 3 to the x. So if we tacked on a plus 2 on the end, it's going to shift the whole graph up 2. So if this was our original graph, and it was sitting on our x-axis here. The plus 2 scoots everything up by 2. So instead of the asymptote being at y equals 0, it is now going to be at y plus 2. Similar, if it was y equals 3x minus 2, instead of shifting that graph straight up, shifting the asymptote up, it moves it down. Okay. I should have changed, let me change this. Plus 2. Okay, so our original graph the brown grayish looking line, 3x y equals 3 to the x. We add the 2, it shifts it up 2 to get the green. If we was to subtract 2, it just moves everything down 2. So now, instead of the y-axis being at 1, it's shifted down 2, so it's at negative 1. Okay, and then there's a couple other things we need to look at with these graphs. So what happens whenever we have a negative in front of our base number? Okay, so looking at the chart of this, so negative 2, negative 1, 0, 1, 2, plug in these values for x and see what we get. So we've got negative 3 to the negative 2, which is just 1 over negative 3 to the 2. I'm sorry, let me rewrite that. Okay, one thing we have to realize is that the negative is not with the exponent. So we could rewrite this as negative 1 times 3 to the x power. So it's negative 1 times 1 over 3 squared, which is negative 1 over 9. And we plug in negative 1 times 1 over 3, which is negative 1/3. Plug in the 0, negative 1 times 3 to the 0, which is negative 1. Negative 1 times 3 to the 1, negative 3. Negative 1 times 3 squared, negative 9. Okay, so now this graph, instead of going up, it's still getting really close to 0. Negative 1/9 is pretty close to 0, but it's below the line. 1/3 still fairly close to 0, but below the line. Negative 1. So at 1, negative 3. 1, negative 3. Let me write in there. at 2, -9, way down there. Okay, so again we've got this exponential going on, but it's decreasing really fast instead of increasing. Now our asymptote's still the same, it's still at 0, but the graph has been flipped over the x-axis. So that's what the negative does. So the negative reflects the graph over x-axis. Okay, we got one more situation to look at. What happens when there's a negative with the exponent? So y equals 3 to the negative x. Okay, again, let's create a chart here. That does not look like y. Plug in -2, -1, 0, 1, 2. So these would be just good values to plug in, just to use every time. So we can see what's going on there around, the y-axis. Okay, so we're plugging in -2 for x. So 3 to the -2. Now we know when we minus a negative, that becomes a positive. So 3 squared, which is 9. Plug in -1. 3 minus -1. Again, is a positive 1. So just 3. 3 to the -0. Anything minus 0 is the same as positive 0. Anything to the 0 power is 1. 3 to the -1 is 1/3. 3 to the -2, 1/9. As we've seen before. So now this graph at -2, it's at 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. At -1, it's 3. -1, it's at 3. 0 is 1. At 1, it's 1/3. So starting to see the shape that this graph's going to take. You can tell it's just going to get closer and closer to 0 as we go on. So the asymptote on this again is at 0, at y equals 0. And the graph maybe comes down through here. Yeah. Now the graph's going to look a little smoother than my line, but I think you get the idea. Okay, if we was to draw the original graph on there, it looks something like this. So this is, red line is y equals 3 to the positive x. So the big idea here is that it is, whenever the negative is on the exponent, it reflects over the y-axis.